In the first part of the tutorial, we have learned how to make a series of obstacles on a grid and draw these to the screen. We are now trying to make the player character interact with these and be stopped from moving through them. So we have a for loop inside our game logic, and we are checking each obstacle. We're looking at the possible positioning new x and new y of the player, and then we check this against each obstacle in the list, and if we've bumped into them, we have set path blocked to be true. So if we bump into any obstacle, then we know that our path got blocked. So what we're going to do now is sort our movement, and we have already commented out the original x equals x plus x speed, y equals y plus y speed. So what we're going to say now is, if path blocked is not equal to true, so if our path isn't blocked, what do we want to do? Well, if it's not blocked, we want to move to that position. So we'll say x equals new x and y equals new y. So instead of just testing the position to see if there's any blocks there, we're now saying it's okay to move into that place. But what if our path did get blocked? Well, in that case, we probably want to stop moving. So else x speed equals 0 and y speed equals 0. Now we could have some situation where our check collision could return us a number, maybe -1 and +1, depending on how we got blocked. Will we be blocked above or below, and so on. But for the moment, we're just going to say that any blocking stops us from moving. If we try this, and I click in this window and then start to move, so you can see that my cop is bouncing off the walls, and then he hit the blocks and he stopped. And I can move around, and when I hit the wall, it stops again. Now I can move up and down. If I try to go to the side, I'm stopped. Now you'll notice at the moment, although the cop is being blocked every time he hits a wall, the zombies don't seem to notice the wall at all, and they are just climbing on top of the crates. So we'll quickly have a look at how we would add the same type of code to deal with the zombies. So we can see that our movement for the zombies is here. So it's a random walk that's created just by jiggling them around a little bit between -5 and 5 pixels. So what we could do is we could see whether that would take them into a block or not, and if it doesn't, then we can allow them to update their position. So what we're going to do here is we're going to say randx equals, and then I'm just going to move that section of code there. So randx equals random.randint between -5 and 5. And then randy, and I'm going to do the same thing here. And I'm going to say then that monster0 equals monster0 minus randx. And monster1 is monster1 plus randy. Okay, why one of them is minus and one of them is plus, I'm not quite sure. Of course, up and down, left and right, that's why. Okay, so now what do we want to do? Well, we're going to test out our new position before we update it. So we need to do this for each different block that's possibly there. So we've got the monster in the NPC list, and then we're going to say for barrier in obstacles, And then we want to say a check collide. So we can do it just like this. Let's, for this particular monster, let's say monster blocked equals false. So we assume that the monster's good to go before we start our for loop. And then we're going to say monster bump equals, and then we're going to do a check collide. So I'm going to take this code here just to save me typing and making lots of mistakes. So I'm going to check collide. What am I checking collide on? Well, the monster has got monster 0 as its x coordinate, and it's got monster 1 as its y coordinate. Okay, and it's then got its own size, which I believe is actually in here as monster size, enemy size. So I really need to use the correct scaling, enemy size by enemy size on those. And then I'm going to compare this to the barrier. So barrier 0 and barrier 1, and they have an obstacle size. Now you may remember from the first part of this tutorial that we had to remember that the blocks are scaled on a grid. So barrier 0 we have to multiply by obstacle size, and barrier 1 we have to multiply by obstacle size. Okay, and we can probably just copy the template of what we'd done before. So if monster bump is greater than 0, then we know that we've collided. So we can say monster blocked equals true. So this monster has collided with some kind of barrier in our list of obstacles. Then, having finished our for loop, we can then say if monster blocked is true, then what do we want to do? Well, we don't really want to do anything. We don't want to move. So it might be better just to say if monster blocked is not equal to true, then that's when we want to be able to move our x and our y. So our monster only gets to move if its pathway is not blocked. And if it's allowed to move, then we add the random amount on for its drunken walk. And then we do all the same checking as before to see that it stays on the screen, max width, max height, and so on. Okay, let's try that. So one of the things we can see here is that the zombies are climbing all over this crate. But one's got stuck at the corner there. When I bounce into the crate, it seems to get freed up again. The cop is definitely still being stopped by the crate. So what's going on? If we go down and have a look at our game logic here, we are looking at a random x and a random y being added on. And then we've said, let's check this monster against the barriers. But we still used x and y. We used monster 0 and monster 1 rather than where we think the monster is trying to get to. So we really need to make sure that we've got our rand x and our rand y included as part of the check collision test. So if we try that now, and the zombie seemed to be climbing on the crate a little bit there, but maybe not. And it might be difficult randomly for them to help us test this out. So what I'm going to do is I'm going to stop this, and I'm going to change the rand x to just be from 0 to 5 instead of -5 to 5. And that means they will all go in one direction, randomly moving, staggering forward. So let's see what happens now. So they seem to be quite happily staggering through there. Let's see what happens if the cop is moving. So now when the cop's moving, they are stopping. And when the cop banged into the crate, they were then released. So they're being stopped, but then the cop hitting a crate is causing them all to be stopped. So let's have a look at what's going on here then. And it's the problem is caused by our current version of check collide. So in def check collide, if it bangs into nothing, it returns 0. So that's our cue for you didn't hit anything. If it hits something, then it returns something based on the cop's speed. Now the problem is, if the cop bangs into a crate, his speed becomes 0, and so everything is then returning 0 at that point, until the cop starts moving again. So we're going to have to change our version of check collide, and we're going to say return 1, so 1 point for every time you bang into something effectively, and that should check for a collision now. So now we are changing, we're looking at our rand x and our rand y new positions, and we are then going to see what's happening. And I can see that the zombies have got stuck, and if I change and move my policeman, and he gets stuck as well. However, the zombies shouldn't really be stopped. They should just be stopped if they're trying to move into a crate. And there's one last problem that we need to fix here. And you can see, and I was wondering about this earlier, why do we take away x, but we are adding on y here? And it's the idea that we've got a left to right on x, and we've got a down the screen for y. So down the screen we're adding on, but otherwise we're taking away. So here, if I change this to match our movement, if I make it monster 0 minus rand x and monster 1 plus rand y, which is the same as what we're trying to move here, then hopefully the zombies will only be stopped moving if they're about to bump into something. And you can see now that they're all shuffling up and down the screen a little bit, and should eventually escape if they get past the edge of the crate. And there one goes, and he's now got stuck on the next crate. And our cop is now able to move and get stuck when he hits a crate too. And if he hits a zombie, at the moment he's going to get 1 point rather than something based on speed. So he gets a point while he's in collision with a zombie. So that's us produced obstacle detection, and that's affecting both our player and our non-player characters.